really just reinforcing that today. I was in two minds. There's 6 questions on this, and we got today's lessons and tomorrow's lesson. I think given we're just getting back into the swing of things, I think I will give both lessons to doing this exercise. Okay, so there's 6 questions, so let's try and do all 6 over the 2 lessons, please. It will be reinforcing your projectiles knowledge, so it's all good revision. I've just liaised with Mr. Kent. He feels that you're ready for me to start integration by the time I finish mechanics. I think we've got about another 6 or 7 lessons left, something like that. So so that will work seamlessly, really. I think he's saying that yes, I've done most of the differentiation topics and we'll be going back to finish it off next week, so there shouldn't be any issues. So I think all that timing of things is going to work well. Hello, Nathan. I think you've joined us since I started talking. So what we're looking at today is the second bit of chapter 8. So it's projectiles again, but in the context of vectors. Okay, so there's only really one key point to get across in the example. Just wait for it to flick through to the appropriate slide. And there we go. So on the example here, obviously their wording of the example is on the left, and I've gone and repeated it on the right in column vector form. I just think that's easier to get my points across rather than the IJ format that they've done it on the left, but it's the same thing. Okay, so the key bit, or 2 key bits. The first bit I want to focus on to remind you is the acceleration side of things. So when we're moving horizontally in the I direction, so left to right, there is no acceleration, if you remember from projectiles, hence why it's a 0 there at the top of the vector. But when we're moving vertically, we're obviously fighting against gravity. We're effectively resolving upwards, because that's the direction of motion here. So that's why it's minus 9.8 on the bottom. So just like when you were doing chapter 6, and you would first of all resolve horizontally and set the acceleration to 0, and then secondly you would resolve vertically and set the acceleration to minus 9.8. Exactly the same point now, but we're just doing it in a vector context. Okay, so we're just using our Suvat equations in vector format. So that's part A. All right, we're just literally subbing in what U was, subbing in the acceleration. Obviously, time is not a vector. Time is a scalar quantity. V equals U plus AT. We could work out the vector for velocity. And then to actually work out the magnitude of that velocity, you would then just apply Pythagoras. Now, for part B, there's only really one point I just wanted to remind you of. Obviously, that equation we're using at the beginning there is S equals UT plus half AT squared. That's the displacement. Now, that's the displacement from where we started. So that's why they've called that the displacement from point A. When you go and look at the diagram at the top, the point is we're starting from 20 meters above the origin. So just be careful with your final answer for displacement, because we're trying to give the final displacement from the origin. Once we've worked out the displacement from A, we've just got to add on the fact that we started 20 meters above the origin. So our total displacement, so effectively that R there that I'm just circling, I'm just going round and round with the cursor at the bottom. That R there is really R suffix 0. That's the displacement from the origin, and that comprises the displacement from A plus 0.20. So those are the only 2 key points I wanted to hook out from the example. I think it's only the one example. And we're then into exercise 8B, which is just 6 questions. Okay. So they do get a bit harder than question 1, but as I said, I was in 2 minds. Do I give you us 2 lessons or not? But given our other lesson is straight away tomorrow, I think we'll just get back into the swing of things and we'll just take 2 lessons over this. Okay, maybe we'll speed up a bit later in the chapter. Okay, so if you could just spend today's lesson and tomorrow's lesson completing the 6 questions from exercise 8B, that would be good. Thank you.